going to talk about an EV conversion project that I completed recently. My name is Summer Schneider. I'm an engineer, mechanical engineer, and I like to convert old cars to electric. This is a Fiat 600 that I converted recently. You maybe see it out there. It's parked out. You can check it out after the talk if you like. One thing I like to talk about is converting old cars is not really for everybody. It depends on how you use it. If you use your car for 100 miles or less or something like that, then it's a good idea. If you love it enough to spend an unreasonable amount of money on it, it's also fit for you. Otherwise, it may not be. And it's really nice if you pick a car that doesn't have a bunch of digital stuff, so something that's older. Makes it a lot easier because you don't have to interface with traction control or ABS or digital dashboard or something like that. I also want to make the caveat here that I'm a mechanical engineer, and this is actually my second conversion. My first conversion is that Corvair, and I talked about it last fall. And the reason I want to bring that up is because I used sort of a typical conversion setup that a lot of people do, which is this net gain Hyper 9 motor plus Tesla modules. It's a very common conversion combination. I did that with the Corvair, and then once I learned how that all went together and I picked all the parts, the next conversion I just used that same recipe, and the challenge was not about fitting all the electronics together. The challenge was, how am I going to get all this crap into this tiny little car? So it was like a packaging exercise for me. Another thing I like to talk about is the risk and time versus money curve. There are a lot of people on the internet, when you say that you're going to convert a car with a Hyper 9 and Tesla modules, that will get upset with you because they're like, you can buy an entire crashed Leaf for the price of one Hyper 9 motor. I'm like, yes, you can. You have all the batteries, you have everything. But the problem is that it's pretty far up this risk time curve. So way over here, it may not cost a lot of money, but the risk in the amount of time required to do that conversion is actually quite high. I have a friend that has bought a Leaf because they took that advice, and they tried to cram it into a Ford Ranger. That was 2 years ago, and you can't get the thing to go faster than 10 miles an hour. Why? Because there's some error in the controller somewhere that's putting it in a limp mode. And so, yeah, he spent $8,000 on the whole thing, but he still can't use it. And so you got to choose how much risk you want to take and how much money you want to spend. On the other end of the spectrum, you can hire a shop to do it. The risk is very, very low. The amount of time, your time is very, very low, but the probability of success is through the roof. This is where the Corvair was. I chose parts that were relatively well-known, but I was sticking it in a car that wasn't well-known. So the risk was a little bit higher, but I spent less money instead of just buying a kit for a designated car like a VW Bug or something like that. So where does the Fiat fit in this? It's basically cost more and was riskier. And the reason why is because although I used the same electronics and everything like that, I picked a donor car that was basically going to the crusher. So I had to rebuild the entire car and weld in all the structure and everything in order to make this car work. And so the risk was high that after all that work, it wasn't going to drive well, wasn't going to go straight. All my welds were going to break, something like that. And so I say it took more time, so the risk was higher, but it also cost a lot more because I had to pay for paint and body work and all that stuff. So I'm going to talk about why I chose a 600, my goals and my plans. Then I'll go through the body work quickly, the mechanical work quickly, the electrical work, and the interior, and then I'll go through a cost and a summary. So first off, why a 600? Well, I love tiny cars, and it's just too cute to pass up. One reason why I think it's a fantastic car for something like this, any car that is popular in other places in the world but not the United States is really a fantastic thing, because then you can have a unique car in the US but still get parts. Because they made 5 million of these things. It was Italy's post-war, get the people moving, economic boom car. So they made 5 million of them. So there's tons of parts in other parts of the world. I bought parts from Croatia, Argentina, the UK, and Italy to put this car back together. All the parts are available, I just had to wait longer. The thing that's really interesting is that it came with 22 horsepower when it was new, got 41 miles to the gallon, which is fantastic in 1960. The spec was it had a seat forward, had a top speed of 59 miles per hour. It just took 1 minute to get there. My goals were I wanted 120 miles of range, I wanted to be able to go on the highway with it, I wanted it to be safer than it was. I didn't want it to look like an EV. I wanted it to look stock. I still wanted to haul 4 people, and I wanted to use it all year round. So this is a lot of what I talked about with the Corvair conversion, like why did I select this stuff? it still applies. The Hyper 9 is still a fantastic motor. It's well supported by net gain. You can get a lot of support from Hunter there. He will call in and help you set it up. There's a lot of forum information out there, so it's just a low risk option, just costs more. Tesla Model S battery modules are still fantastic for energy density, and you can just buy them off of eBay from cars that were crashed. So I use 6 of them in this. And believe it or not, the modules that are in the Fiat out there are from a 2012 car. So they're no spring chickens, and I still have, according to my battery manager, 90% pack health. Previous talk talking about buying used EVs, I feel like with a gas car and electric car, the situation is reversed. Like in a gas car, the fuel is basically maintenance free, and the engine, in order for it to last a long time, you have to like start it up, let it warm up, change the oil, maintain it, like treat it well. If you just treat it like crap, it's gonna break. With an EV, it's exactly the opposite. The motor is utterly carefree. The battery, you should warm it up. You should take care of it. If you take care of it, it will last a long time, just like if you take care of a gas motor, it'll last a long time. So in my opinion, it's like the same exact problem as a gas car, but it's flipped over. So if you take care of the fuel source, it will last for a very long time, and that's an example of it. It's 2012 pack, and it still has 90% of its capacity. Another thing that I did with this car that's special is that because the car came with 22 horsepower originally, the transmission that came in the car was like this cute little transaxle, just the cutest thing, but it was rated for 22 horsepower. And I was gonna put 120 horsepower on it. And it's a rather rare thing in the United States. It would just twist that thing up. So I couldn't find parts for it, and finding replacement transmissions were a pain in the butt. So I decided that I was gonna take that out and graft in a Beetle transmission, because that's a common transmission to use with this motor. And I can get aftermarket parts, and they're kind of a dime a dozen in the United States. And so if I broke it, I could just get another one. So I was thinking about serviceability when I was doing this conversion. So I do a bunch of stuff to figure out how this conversion is going to go. Where am I going to put the batteries? Will the motor fit? How am I going to manage the HVAC? Because remember, I want to use this year round. Got to upgrade the brakes. How much weight am I going to add, and how far will it go? So I'll rip through this. Found this great picture on the internet. You can see these orange outlines. Those are Tesla modules. They're like this wide, or this long, this wide, and this thick. I can fit 4 of them across the bottom of the car. Now, if you remember, I mentioned earlier that the car was destined for the crusher because it was so rusted that basically should have been thrown away. But that meant that I could manipulate it. So I wasn't cutting up a good car. I was taking stuff that already needed to be replaced and changing it. So I changed it so that the battery could be built into the floor. Instead of just replacing the floor with stock parts, I replaced it with my own battery tray. So I could fit 4 across the bottom and then 2 underneath each seat. So that's how I built the battery box, and then I sealed it up, and now the seats sit right on top of the batteries, just like in a modern EV. This is what the CAD looks like. So you can see there are 4 modules across the bottom and then 2 underneath each seat. And then I did a little bit of CAD work to make sure that the motor was gonna fit. So that's a CAD model of an early Beetle transmission, and that's the CAD model of the Hyper 9 motor. You can see tons of clearance there. It looks big in this plot, but in real life, it's about 5 millimeters. And that allowed me to put a nice juicy adapter plate between the motor and the transmission, which is something that you have to build in order to make sure that those things connect properly. The other thing I worried about was HVAC. I found this company that makes this adorable little air conditioning unit. So I bought one of those. And then this is probably the cutest hair dryer I've ever seen in my life. It's a 1,000-watt hair dryer. And because my traction pack is around the same voltage as AC, I just plug the hair dryer element directly into the traction pack and I get heat that way. I also changed the brakes. The brakes that came in the car were woefully inadequate, especially when you add this much power. So I changed the brake master cylinders to modern master cylinders, and I upgraded the front to disc brakes. And then I decided I better do some math to figure out how much weight I'm going to add to the car and what am I going to do to the weight distribution. So I did some math on how much I'm going to add. I calculated 245 pounds for most of this stuff, plus a bunch of electronics, so I predicted about 280 pounds I was going to add to the car. Then I did some statics to figure out what the weight distribution was going to be. Before the conversion, most of the weight was in the back, because it was actually a rear-engine car. And I predicted it would shift a little bit forward, so it's still heavy in the back, which is important to sort of preserve the weight distribution of the car, so you have to change things dramatically. If you change the weight distribution of the car dramatically, then you have to do a lot of stuff to the brakes and the suspension and everything like that. So if you're going to do a conversion, keep that in mind. You want to keep the weight distribution similar to what it was when it came from the factory. Otherwise, you're going to generate a lot of work for yourself. Then I want to know, like, how fast can I go in each gear? So I already did a conversion in the Corvair, and I know exactly how fast that thing felt. I wanted this car to feel faster, but I also wanted it to be more efficient on the freeway. So I geared it. I changed the final drive and a couple of things so that in second gear, it would actually go, this is motor RPM here, and this is miles per hour. So the yellow curve is what I was aiming for in second gear, and then the orange curve is what I was aiming for in third gear. So I had basically a city gear and a highway gear. And then it was right in the Corvair was right in between, and I know exactly how that felt. The biggest difference, however, is that the Corvair weighs 1,000 pounds more. So the Fiat is actually 14 pounds per horsepower, which is pretty good ratio if you want something that's speedy. And then my range. So I did some math up here and used some internet wisdom and figured out that I'd get about 110 to 130 miles based on what typical miles per kilowatt hour you get from these kinds of conversions, because the car is not aerodynamic, and so it's not very good at highway speeds for efficiency. Not like the modern EVs that are designed to be really, really smooth. Don't forget the top speed was 59 miles an hour before. And let me tell you, you go faster than 59 miles an hour in this car, it gets squirrely. So, bodywork. I'm going to go through this for a minute. When the car arrived to me, it was white. From the factory, it came red. Somebody had roller painted it white throughout its life. Actually, I think it got painted cream and then white. But you can see how much rust and everything is in there. So I stripped everything off the car. And I even made a makeshift rotisserie so I could get to the bottom of the car like engine stands from Harbor Freight. Then I took it to this shop down in Eugene, and they had this gigantic swimming pool full of this caustic chemical that's at elevated temperature, and they pick the whole car up and they soak it for a couple of days. What that does is it takes all the paint off, all the Bondo off, and all the rust off. But what you get back is what the car is really like. And when the car came back, I was heartbroken. There's so much rust damage in this car. You can see rocker panels utterly destroyed. You can see up there in the window, part of missing. The floors are gone. All that rot underneath the windshield. The whole front of the car was rotted. I almost threw the car away, and my gal said, maybe you should stick with it and see what happens. Because there's a lot of people out there that get upset when you EV convert a healthy car. Like you take this beautiful 65 Mustang, you rip the 302 out of it, and you put an electric motor in there, like, what are you doing? You're ruining that car. Why don't you start with a car that's unhealthy? So I'm like, all right, maybe I'll start with a car that's unhealthy. It turns out, starting with a healthy car is a much better idea. So then I learned how to do body work. So because I could order parts from all over the world, I got these new rear fenders. So I stitched these in. And let me tell you, a car from 1960, Italy, has some pretty thin sheet metal. And it's not a good car to learn how to do body work on. Because every one of these little welds, you go like this, there's a 50% chance that you're going to melt the metal around it and create a hole. So I'm like trying to tack these welds in here without melt. So it was a very, very steep learning curve for me. But I got it. So I was able to replace all kinds of parts in the car, including the front end. So those are new panels that I bought from Croatia, including a new hood and a new nose. And then I wire brushed the whole car, cleaned the whole thing, and then I did this two-part epoxy, which is a good direct-to-metal primer. It's a two-part epoxy, super hard, grabs onto the metal, does not scratch off. And then it's good, you can put your primer on that, and then your final finish coat on top of that. I am not a good enough bodywork person to go without any body filler. And so wherever there were welds or something like that, I would tap it in there, grind it, and then I had to make it smooth with some body filler. Most hot rod guys do this nowadays. Nobody uses lead or anything like that anymore. So even though it's got Bondo on it, it's a pretty common thing. And Bondo is way better now than it used to be, so don't be afraid of it if you ever decide to do this. And in order to take it to the paint shop, you have to put the wheels on it. So I put all the suspension together and then dropped it on the ground. This is the first time I was on the ground for a year. So then I roll it to the paint shop, and then it comes back blue. Now the fun begins. Because now, well, actually, I'm going to talk about the fun later. So that was the bodywork part of it. Now I'm going to talk about all the mechanical stuff I had to do in order to make this car a conversion candidate. So like I said, the floors were rotted before. So actually, instead of replacing the floors with standard floor pans, I built a new battery tray into it. So I actually lowered the floor 2.5 inches and raised my seat 1 inch so I could fit Tesla modules underneath it. And I built that all out of stout angle iron. And so all the batteries are in the back, so I can have a cooling system that's all on one side. All the electrical stuff's on the front of the car. And then the transmission, which is still a Beetle transmission, so I wouldn't call that a big car, but the transmission was larger in every dimension compared to the Fiat. So I had to cut the body away and build these little cover panels in order to make clearance for this larger transmission. You got to make sure that the outputs from the transmission line up with the wheels. So I had to like put it in the right spot inside the car. It's best to be in the center so your axles are the same length, otherwise you get torque steer and all this stuff. And so figuring out where to put it in the car and make it fit was actually quite a challenge. I don't know if you can tell from this picture, but it's actually about 25 millimeters shifted to the left. I couldn't get it in the middle exactly. Turns out it hasn't been a problem. Then I got this fancy pants transmission from a VW shop that made it so it's extra stout. It has a 4-gear Spider differential in it, things like that. And the adapter plate to mount the motor. I'm cruising through this. It takes a lot of work to do this stuff, but the pictures are pretty. Another thing that's sort of interesting is the early Fiat 600s actually had the parking brake built into the transmission. If any of you have ever driven an RV and there's like this big bell on the front of the transmission and there's a drum brake that kind of holds it there, it's exactly what was in this car. That means when I took that little transmission out, I had no parking brake anymore. So what the heck am I going to do? Well, I shopped around seeing if I could figure out how to make the rear brakes do it, but it was going to cost me like $2,000 to do a rear brake disc conversion and all this crap. And I thought, I've got a clutch in the car that I'm not using. So I actually built the caliper that squeezes the clutch. So as long as the car is in gear, I pull the emergency brake, which pulls the clutch lever, which squeezes the clutch, and is my parking brake. And then I had to build in a bunch of structure. There used to be an engine back here, so there was a firewall. I cut that firewall out and turned it into the rear deck and everything, but that firewall created a lot of torsional stiffness in the car. So I had to add a bunch of material to make it stiff, and I added a roll bar, partly because if the car rolled over, I wanted to be protected, but also I had nowhere to put my shoulder belt anchors. So I wanted a spot to put those that was nice and stout. Because remember, I wanted this car to be safer than it was. Then I redid the front end of it. That's where I ended up mounting the new brakes, the master cylinders on the left there. Then I reinforced the strut towers, and I'll tell you why in a second. And then I converted the front to disc brakes using a combination of Fiat 124 and Fiat X19 parts. It took me a long time to figure out what would go together, but it finally does. And then the reason why I had to reinforce the shock towers is because I replaced the entire front suspension system. I bought this front suspension system from a company in Argentina. Argentina, for some reason, loves the Fiat 600, and they have entire race series that all they do is race Fiat 600s. So that means I could get tons of hot rod parts. So this whole front suspension thing is just this hot rod race setup. It's got coilovers. You can see the springs on either side to replace this leaf spring that was in the car, which is a very common 60s thing for companies to do. It holds the car up, but it also locates the suspension, so it does dual purpose, which means it's very space efficient and also very inexpensive. It also is loud and creaky and clunky, and this is a lot better. And then I had to have fancy pants axles made. Why? Because I had a VW transmission now, and I had Fiat wheels. So I have to go from a VW output on the transmission to Fiat wheels, so I have special custom axles. There's a shop down in Tualatin called Driveline Specialties that does this stuff for me. I had no idea. He thought it was adorable because he's mostly doing axles for like Jeeps and stuff like that, when people do LS swaps in Jeeps and things. He's like, oh my God, this is the smallest axle I've worked on in 10 years. And then I got talked into upgrading it to a rack and pinion steering. So this is a rack and pinion rack out of a Fiat 128 that I drafted in there. But in order for me to do that, I had to redirect the steering column to jog around the brake pedal so that it would actually fit where the rack was supposed to be mounted inside the car. Big learning curve with all that stuff. I was not planning on doing it. So then here's some electrical work. This is how I decided to lay things out. Because I had already done this before, I didn't need to necessarily have all the electronics in one spot because I knew how to wire things up. So I spread it out all over the car to make it a good package. I did a lot of low voltage stuff in the front. My high voltage stuff went underneath the back seat. And then I redid the entire car, and I'll show you that in a second. The back seat was rotted and gross, so I replaced it with this wood frame. And it was just precious volume for me to put a bunch of electronics underneath there. The front of the car was going to house the charger, my HVAC, and my DC to DC converter. And then here is the new schematic for the car. The way the car was set up originally had a bunch of UX nightmare things, like in order to use the headlights, you had to put the key in a separate position and then flip the switch on the dashboard and then use the stalk to turn the lights on. It's like, I don't want to do that. I want to do something simple. So you just flip the stalk and turn the lights on. It's pretty simple. But it required rewiring the entire car. So like those kinds of things I changed while I did it because I was in charge of how everything was going to go together. So in this particular case, on the dash pod, there's an oil light and a generator light. Well, I don't have oil and a generator anymore, kind of. So I turned those into turn signal lights. So I was able to rewire those. They still say oil and generator on there, but now it's left and right turn signals. Because before, there was just one light that didn't work. So in order for me to tell if the turn signal was on, I had to listen for the clicking. And then this is the schematic for the actual EV part of the car. You can see the car itself is represented by that little box right there. When you think about an EV conversion, you think like, well, isn't there a bunch of wires that go from the EV conversion part to the car? Actually, no. There's like 1, 2, 3, 4, 5 wires. Because the car is just its own standalone system. And you basically turn the car on, the car says, all right, EV system, turn on. And the EV system turns on, everything's okay, and it's done. So there's just a few signal wires that go from the car's electronics to the EV electronics. And then this is what happens when you try to do a schematic for the Tesla modules. I can get into this, but it's kind of boring. Essentially, you have a cell tap for every single cell, and every module has 6 cells. So your battery manager makes sure that every single cell is healthy, the temperatures are good. This is what the front of the car started to come together like. I have all my fuses in the front. You can see the relays and fuses. Like the car didn't have any relays because it's an old car, so I added a bunch of relays to it. Those are my fuse panel, my connection panels there, and my brakes, and then the HVAC there. Then I end up mounting the charger there and the battery manager up there. The DC to DC converter I planned originally to put there, but there was plenty of room underneath the car, so I stuck it there. Those are very reliable, and they happen to be rated, IP-rated for like getting wet, so it's okay if they get splashed. This is what it looks like underneath the back seat. So underneath the back seat, you can see this thing on the left. That's the motor controller. The motor controller comes with the motor. They're designed to work together. And so the battery comes out, goes into the motor controller, and the motor controller takes the DC from the battery and turns it into AC for the motor. There are a bunch of contactors and fuses. Contactors are just really, really high current relays. And then this is what the motor mounted up looked like. You see that little hole that the wires go into? That used to be the HVAC tunnel. So the heat from the old engine used to get piped through that into the cabin so you could warm up the cabin. So now it just houses the high voltage wires from my motor. Then another thing is the gas tank used to be under the hood of this car. So if you go to the gas station, you had to pop the hood, unscrew this thing, put it in there, try not to get gas all over your groceries because that's also where your groceries go. And so I didn't have a gas flap for me to put the charge port in. So how was I going to charge this car? Well, a long time ago, some previous owner had replaced the front emblem with a third headlight. Don't know why, but that's what they did. I thought, oh, that's kind of cool. Maybe what I should do is turn that headlight into a charge port. So I catted up some parts, 3D printed them, and now you take this headlight, you flip it up, and you can charge the car. The other thing that's extra is that I put the charge indicator inside the light, so when it's charging, that light actually blinks with the charge of the battery. So the interior, of course, everything in the interior was also rotted. The seats had these rubber bands that you basically sat on. They were all dry rotted and crusted, so I ended up going to that industrial tire place up on Columbia near Gartner's and bought an inner tube that people typically use to float down the river. And it turns out the diameter of the inner tube is about the size of the seat. So I cut bands and slid them down. So those are the rubber bands that I sit on. Then I put a seat heater in there. I could order new foam from Italy and a new seat kit from Italy. So in the end, I have these new seats that are nice and robust and they actually have heaters in them. I did a mediocre job with my upholstery. It was my first try. And then because the back seat can now fold down, I can put skis in it. And even though there's not a lot of leg room, you can have 2 adults in the back. I wouldn't go on for a long ride, but you can go for a ride. And then this is what it looks like inside, and that's my direction knob. The thing that's glowing also tells you if the EV is on. I rebuilt the steering wheel. I rebuilt the gauge cluster. Believe it or not, I ran this gauge backwards in my basement for 3 weeks, Ferris Bueller style, to reset the odometer. So now the odometer is 0. So all the miles on this odometer are for EV. And I repurposed the gas gauge to show my state of charge. And here I'm rushing right now because I've got 3 minutes left, so sorry about that. This is how much it cost, $30,000. The reason why it cost so much is because I started with a trashed car. The actual conversion parts were about $15,000, which is more run-of-the-mill, especially if you're doing it yourself. But I added $10,000 just in bodywork and paint. And then because I picked a motor that's too big, I had to buy a bigger transmission and axles and all that crap, and so it adds up fast. Then I achieved all my goals. I did everything myself except for final paint. And how did I do on my weight calculations? Actually not that great. I missed by 100 pounds. And my weight distribution I predicted to be 54% in the back, and it ended up being 57. So the car now weighs 1,680 pounds, and it started out from the factory weighing 1,340 pounds. 1,300 pounds. It could get blown off 405 and no problem. So that's what the interior started like. That's what it was looked like during the process, and this is what it looks like now. The exterior looks like this. This is what the boot looks like. Tons of groceries. It has way more room now than it did before. This is what the bonnet looks like. And that's the end of my presentation. First gear is utterly useless in the car except for doing burnouts. It's just got too much torque. So I drive around in second gear all the time or third gear all the time. Any questions? I saw your hand first.
I read that it takes 15 horsepower to spin gears in a manual transmission.
Oh.
You go to left drive, because you're losing 10% right there.
Yeah, except that the voltage in my car isn't high enough to run the motor fast enough. And so I have to shift gears if I want to do highway speeds. If I were able to fit 400 volts in the car, I could pick a motor that spins fast enough and efficient enough to run at highway speeds. So I need to have a gear reduction and probably 2 gears at my 150 volts. And what easier than to use a transmission that's been designed by a bunch of engineers and try to design my own. You're right, it's heavier and there's more spinning losses, but it's way easier and very reliable. I don't need the extra 15 horsepower. Good question though, yeah.
So your motor is an AC motor or DC?
AC motor.
And you show that
Because the efficiency curve for AC motors is so much flatter than DC. I had a plot in my previous presentation, but if you look at a DC motor, the efficiency always peaks at 1 RPM. And so with a DC motor conversion, you almost have to have a transmission so you can try to keep the motor at a reasonably efficient RPM. AC's motors, which are akin to a DC drone motor but uses something a little bit different inside, has a pretty flat torque curve, so you can use the motor in a usable range that's really wide. So it's a lot better for efficiency. A lot of companies are using AC motors instead of DC for that exact reason. That's the way I understand it.
everything you use in Tesla battery modules, what about the brains for that?
That's an Orion BMS. It's a common aftermarket BMS that gets used with Tesla modules. Really good aftermarket support. User interface to set things up is beautiful. They've got wizards in there, similar to like the old school wizards to set up all their stuff. Like, what do you have? I have 6 Tesla modules. Oh, what's the capacity? Because they make a 6.3 kilowatt hour and 5.3. It's a 5.3. It like automatically populates all the internal resistance curves, all the thermal derating curves, all that stuff. And so it's already built into it. It's pretty awesome. That's why I use the BMS from Orion. Literally has a drop down menu. So Tesla, and then you can modify it, like how much do I want to charge it to, how much do I want to discharge it to, do I want to change, when do I want their thermals, to, like the cooling system to turn on, stuff like that. I think that's how I handle it. All right, thanks very much.